Close your eyes. Imagine the universe as a vast, silent ocean, stretching endlessly in every direction. On this ocean, every star is like a lighthouse, every galaxy a floating island. And across this cosmic sea, there is one unbreakable rule, a rule older than stars themselves. Nothing can travel faster than light. But why? Why has the universe set this invisible barrier, this untouchable speed limit? Light itself is astonishing. It moves at almost 300,000 kilometers every second. In one heartbeat, it could circle Earth 7.5 times. From the Moon to Earth, light takes just over a single second. From the Sun, 8 minutes. From the next nearest star beyond our Sun, Proxima Centauri, light takes 4 long years. And yet, despite this breathtaking speed, light is not infinite. It is fast, but not infinite. This is the heart of our mystery. Imagine if you could run faster than your own shadow. Imagine if you could outrun cause itself and arrive before the effect. Strange paradoxes would begin to bloom, like ghost flowers in the fabric of time. That is why physicists often call the speed of light not just fast, but fundamental. It is the ultimate law of the racetrack of the cosmos. Every particle, every star, every wave of energy is bound to this limit. But here's the deeper question. What actually happens when you try to break it? Stay with me as we drift deeper into the ocean of relativity. Albert Einstein, with his wild hair and dreamy eyes, gave us a map of how the universe works. In 1905, with his theory of special relativity, he showed that space and time are not rigid, separate things. They are woven together, like threads in a cosmic fabric. And the speed of light? It is the stitch that holds the entire fabric in place. Think of it this way. If space and time were like the surface of a trampoline, then light is the tightness of the fabric, the rule that makes the trampoline bounce instead of collapse. Without this speed limit, reality itself would fray apart. But here's where things become strange and beautiful. The closer you move to light speed, the more the universe begins to change around you. Time slows down. For you, moments stretch. A journey that feels like minutes inside your ship might feel like decades to the people you left behind. Distances shrink. The stars ahead seem to pull closer, space itself folding like soft fabric being drawn toward your destination. Mass grows. The faster you go, the heavier you become. Your rocket resists acceleration as though invisible hands of the universe are pressing against it. Einstein showed us that light is not just fast, it is the cosmic ruler. It measures how space and time behave. It decides how reality bends when we try to chase it. So imagine again, you are aboard a ship, accelerating, pushing closer and closer to that sacred limit. You watch the stars blur into streaks. Your heartbeat slows, your breath lengthens. Time outside moves faster than you. The world you left behind ages in silence. And then you ask yourself, if I go just a little faster, what happens next? The answer is, you can't. The universe won't allow it. Let us picture something simple. A car speeding down a highway. To go faster, the car must burn more fuel. Double the speed, and you need much, much more than double the energy. Every extra push costs more than the one before. Now imagine this not with cars, but with spaceships. The closer a spaceship gets to light speed, the more energy it requires. The cost grows steeper and steeper until it becomes a mountain too high to climb. At 90% the speed of light, you already need colossal amounts of fuel. At 99%, the cost skyrockets. At 99.9999%, the energy needed becomes almost unimaginable. And to reach 100%, to reach light speed itself, you would need infinite energy. But infinite energy does not exist. Not in stars, not in galaxies, not even in the whole universe combined. This is why physicists say it is not simply difficult to exceed the speed of light. It is impossible. The math itself blocks the way, like a door welded shut by the laws of nature. But why should the universe care? Why such a rigid, merciless barrier? The answer lies not just in energy, but in the very flow of time itself. Let us imagine, just for a dreamy moment, that you could break the cosmic speed limit. What would happen? At first, it might feel thrilling. You are racing faster than light, leaving even photons behind. But soon, the universe begins to unravel. Because when you move faster than light, something bizarre happens. Cause and effect lose their order. Normally, events happen in a logical sequence. First you strike the match, then the flame appears. First the note is played, then the sound travels to your ear. You arrive at your destination before you have even left. You would not just be traveling through space. You would be traveling through time backward. This is what physicists call the time traveler's paradox. If effects can come before causes, then reality itself begins to collapse under contradictions. Could you arrive before you were born? Could you prevent the very journey you just took? The universe seems unwilling to allow these riddles to exist. And so, to preserve causality, to keep time flowing in one direction, the universe enforces its speed limit. Like a cosmic guardian, light speed ensures that tomorrow always follows today. Why nothing can go faster than light? Light is more than speed. It is history itself. When you look at the moon, you are not seeing it as it is right now. You are seeing it as it was 1 second ago. When you gaze at the sun, you are looking into the past, 8 minutes behind reality. And when your eyes lift to the nearest star beyond the sun, you are peering backward 4 years. Every star in the night sky is a time machine, a glowing lantern shining from the deep past. Some of the stars you see tonight may no longer exist. Their light has traveled across centuries to reach your eyes long after the stars themselves burned out. So light is not just speed. It is a messenger. The messenger of truth, of history, of the very heartbeat of the cosmos.
If light were not the fastest thing in existence, if something could outrun it, then the messenger would always arrive late. The record of history would be broken. The past would crumble. This is why the speed of light is sacred. It is the way the universe preserves its memory. Now picture space and time not as empty nothingness, but as a fabric, a smooth, invisible web stretched across the cosmos. This is space-time. When you move slowly, space-time bends gently. But as you move faster, space-time resists. The closer you approach the speed of light, the more space-time stretches like taut silk. Einstein showed us something profound. The laws of physics are the same for everyone, no matter how fast you are moving, and at the heart of this universal law sits the speed of light, constant and unchanging. Whether you are a child holding a flashlight on Earth or an astronaut chasing photons near a black hole, light speed is always the same. It does not bend to your motion, it does not slow for your perspective. It is as though the universe has built its entire machinery upon this one unshakable foundation, a pillar of certainty in a world of relativity. But here's the strange part. Relativity does not just describe space and time, it redefines them. If something could move faster than light, then the very foundation of space-time would collapse, like glass shattering in silence. And yet, physicists are curious creatures. They ask, what if? What if there existed particles that always traveled faster than light? They gave these hypothetical entities a name, tachyons. Tachyons, if they exist, could never slow down below light speed, just as we can never speed up past it. They would live on the far side of the barrier, forever unreachable. But here's the paradox. Tachyons would behave strangely, almost hauntingly. They would appear to move backward in time. They would blur cause and effect. They would ripple through reality like ghosts, untethered from our ordinary sense of before and after. For now, tachyons remain in the realm of speculation, mathematical phantoms. No experiment has ever found one, and perhaps that is for the best, because if they were real, our safe and ordered timeline might dissolve into chaos. Still, it is a tantalizing dream. Maybe, just maybe, the universe keeps secrets hidden beyond the curtain of light speed. If we cannot go through the barrier, can we go around it? Science fiction offers hopeful whispers. The idea of the warp drive, bending space itself, not the ship. Instead of moving faster than light, space contracts ahead of you and expands behind you. Like surfing on a cosmic wave, the ship remains still, but space-time itself carries you. Another dream is the wormhole, a tunnel through space-time, a shortcut between distant points. Step in one end and step out instantly on the other side of the galaxy. Faster than light not by speed, but by clever geometry. But both dreams come with shadows. Warp drives require exotic matter, energy with properties we have never seen. Wormholes, if they exist, may collapse before anything could pass through. Still, the dreams persist. Because humanity is not only bound by laws, we are bound by imagination. And sometimes imagination is the first step towards discovery. So as you rest tonight, let yourself imagine. What would it feel like to sail across the galaxy in the blink of an eye, to watch constellations shift before your eyes like drifting smoke, to step beyond the speed of light and touch the edge of the impossible? The dream remains, waiting just beyond reach. Every book has a language. Every poem has a rhythm. The universe, too, has a language, and its alphabet is written in light. Think of it. Every time we study a star, every time we measure the faint glow of a galaxy, every discovery we've made about the cosmos, it all comes from light. Astronomers are readers peering into a library of photons. The colors of starlight tell us what stars are made of. The dimming of light tells us when a planet crosses a distant sun. Even the faint afterglow of the Big Bang, the cosmic microwave background, is light, whispering from a time when the universe was a baby, just 380,000 years old. Without the constancy of light, without its unshakable speed, this cosmic library would be unreadable. Pages would shift, words would blur, history itself would be lost in the wind. So when we say nothing can travel faster than light, we are also saying the cosmic story must remain intact. The messenger must never be outrun. The language of the universe must never be broken. Now let's sink deeper into time itself. We often imagine time as a river, flowing from past to present to future. We drift upon it, unable to turn back, unable to leap ahead. But what keeps the river flowing in one direction? What stops it from swirling backward? The answer lies in light. The speed of light is not just a speed. It is the guardian of time's arrow. Without it, events could reverse. Effects could precede causes. Tomorrow could arrive before today. This is why physicists hold light in such awe. It is not simply brightness. It is not simply motion. It is the quiet enforcer of reality. Close your eyes and imagine a clock. Its hands tick steadily forward. Now imagine that by moving faster than light, you could reverse those hands. You could undo every moment. You could rewrite your story. It sounds tempting, but it would not be life. It would be chaos. So the universe resists. The river of time is guarded, and the guardian is the speed of light. Imagine standing at a shoreline. The ocean stretches endlessly, but at some distance, the water merges with the horizon. You cannot see beyond, but you know the world continues. The speed of light is like that horizon. It is the edge of the possible. We can approach it, come infinitely close, but never step beyond. Every accelerator on Earth, every particle physicists have hurled near light speed confirms this truth. Electrons, protons, neutrinos, they can be pushed to 99.9999% of light speed, but never more. They lean against the cosmic wall, but they do not cross. The universe whispers, "This is as far as you may go." And yet, there is beauty in limits. Just as a painter finds freedom within the borders of a canvas, humanity finds creativity within the boundaries of physics. Our ships may not pierce light speed, but our minds may wander beyond it. And in dreams, in stories, and in the lullabies of science fiction, we sail faster than light every night.
Still, sometimes the universe plays tricks. There are moments where it seems that light speed has been broken. Quantum physics, with its playful strangeness, shows us particles that appear to tunnel through barriers faster than light. Waves of light, in special conditions, can give the illusion of moving quicker than their limit. Even shadows can appear to travel faster than light. If you wave your hand in front of a distant wall, the shadow's edge might seem to leap instantly. But here's the truth. In every case, no real information, no real object ever breaks the rule. The trick is always in perspective, in illusions, in the strange folds of physics. The law remains intact. Light speed stands, unwavering, untouchable. It is as though the universe allows us to glimpse the possibility, to feel the temptation, but never grants the transgression. A tease, a whisper, a reminder. The rules are firm, and yet they sparkle with mystery. Let us drift back, all the way to the very beginning. Before stars, before galaxies, before even the concept of distance, there was a great silence. Then came the Big Bang, a moment when the universe itself unfurled, expanding faster than words can capture. In those first moments, there was no light. The cosmos was a storm of energy, dense and hot, too wild for photons to escape. But then, about 380,000 years later, the storm cooled. Particles calmed, atoms formed, and at last, light was free to move. That light still exists. It has been traveling across space for nearly 14 billion years. We call it the cosmic microwave background, a faint, whispering glow that fills all of space. And here's the secret. The reason we can see this light at all, the reason it reaches us, is because it has always obeyed the cosmic speed limit. Like a disciplined traveler, it has carried the memory of creation at the same unbreakable pace, never faltering, never falling behind. The speed of light is not only a rule of the present, it is the very script of the past. Without it, the story of the Big Bang would be unreadable. But wait, a mystery emerges. Cosmologists discovered that in the very first fraction of a second after the Big Bang, the universe expanded faster than light. This phase is called cosmic inflation. How is this possible if nothing can outrun light? The answer lies in the subtle difference between objects moving through space and space itself expanding. The speed of light restricts particles, energy, and matter moving across the fabric of space-time, but it does not restrict the fabric itself. In those earliest moments, space-time ballooned outward at a breathtaking pace, carrying galaxies to be with it, like ink spreading through water. Nothing actually moved faster than light within space. Rather, space itself grew. And so, the cosmic speed limit was never truly broken. It was simply sidestepped in a way only the universe could allow. It is a humbling reminder. Even our deepest rules contain mysteries at their edges. Now drift forward to today. The universe is still expanding. Galaxies are still drifting apart, carried on the current of space-time. And not only that, the expansion is accelerating. The cause is something we call dark energy, a force we do not yet understand, but which makes up nearly 70% of the cosmos. Because of this acceleration, some galaxies are moving away from us so quickly that their light will never reach Earth. It is not because they break the speed of light, but because the space between us and them grows too fast. Imagine standing on the shore watching a boat drift outward. No matter how loud you shout, the waves carry it away. Eventually, the distance grows so great that even the fastest message, the speed of light itself, cannot catch up. In this way, the speed of light defines not just how we move, but what we can ever know. Whole galaxies are already lost to us, hidden beyond the horizon of light. They exist, but we will never see them. The cosmic speed limit is not only a law, it is a veil, a curtain drawn across parts of the universe, leaving them forever a mystery. If the expansion of the universe shows light's limits on the largest scales, black holes show them on the smallest. A black hole is a place where gravity is so strong that not even light can escape. The boundary around it is called the event horizon. Once light crosses this horizon, it can never return. Think of it, light itself, the fastest traveler in existence, the messenger of history, the guardian of time, trapped, caught in silence, unable to carry its story outward. Black holes are the ultimate demonstration of the cosmic speed limit. At their edges, space-time curves inward so steeply that every path leads deeper within. No shortcut exists, no angle of escape. The prison is absolute. But even in their darkness, black holes whisper. Stephen Hawking showed that they may slowly release radiation, fading over unimaginable timescales. But the rule still stands. Nothing can climb out faster than light. Here at the event horizon, we glimpse the ultimate truth. Light is not just a limit. It is the very thread of reality, bending, twisting, but never breaking. In the quiet halls of quantum physics, there is a puzzle that feels almost magical. Entanglement. Imagine two particles, born together, linked in such a way that their fates are tied. No matter how far apart they drift, across a room, across a galaxy, when one is measured, the other instantly reflects the change. It looks at first glance as though information travels faster than light, a signal leaping across space in an instant. Einstein himself called it spooky action at a distance. But here lies the secret. While entanglement is strange and mysterious, it does not truly transmit information faster than light. The link is real, but it cannot be used to send a message. It is as though the universe allows particles to whisper to one another, but only in riddles no one can interpret until both sides are compared. So, the law holds firm. Light speed remains the limit. Yet, entanglement reminds us of something humbling. There are corners of reality where our understanding still falters, and perhaps the full story remains unwritten. For thousands of years, humans have gazed at the stars and dreamed of reaching them. In myths, heroes flew on chariots of fire, rode wind horses, or crossed the heavens on golden boats. In stories, faster-than-light ships leap between galaxies in a blink, connecting civilizations in distant constellations. This dream is not only about speed, it is about connection, exploration, longing. To travel faster than light would be to conquer loneliness itself, the loneliness of a vast cosmos where distances are measured in lifetimes. We may never outrun light, but in dreaming, in storytelling, in creating worlds where warp drives hum and wormholes bloom, we keep our wonder alive. These tales remind us that imagination itself has no speed limit, and sometimes imagination is more important than arrival. Why does the universe have limits? Perhaps it is not a prison, but a gift. Limits shape meaning. A melody is beautiful because it ends. A day is precious because it fades. Life is luminous because it is bounded. In the same way, the speed of light gives structure to existence. It ensures that events follow one another, that history is possible, that time has a direction. Without it, reality would dissolve into chaos. So maybe the cosmic speed limit is not a wall holding us back. Maybe it is a canvas upon which the universe paints its masterpiece. And we, tiny observers within it, can marvel at the harmony of rules that allow galaxies to spin, stars to shine, and time to flow. And so, as we return from this long drift through space-time, let us breathe. We have wandered from the birth of the universe to the pull of black holes. We have touched upon paradoxes, illusions, and dreams. We have seen that nothing outruns light, not particles, not signals, not even our most daring ships. But within that limit lies wonder. Light carries the memory of stars. It shapes time's arrow. It protects the order of reality. And though we cannot cross its boundary, we can follow its glow through telescopes, through imagination, through the quiet act of looking up at the night sky. Close your eyes and picture yourself floating among the stars. Photons, born billions of years ago, gently touch your skin. The story of the cosmos arrives in silence, at the only speed it ever could, the speed of light. And with that, we let the universe hum in peace, whispering lullabies written not in words, but in waves of light. Good night, traveler.